Namaskar and hello. Welcome to your favorite Shridevi classes YouTube channel and our playlist Physics Made Easy. We'll discuss multiple choice questions and today our topic is electrostatics, and in 4 videos we'll discuss important conceptual questions which are really important for all type of competitive exams. Let's start. In first question we are given 4 statements and we have to find out false statement among these 4. The first statement is charge is conserved and quantized. So it's a true statement. The total amount of charge remains the same in any isolated system. That means charge is conserved. And charge is also quantized. There is a minimum amount of charge, electronic charge, and we cannot have charge less than that or non-integer multiple of electronic charge. So charge is both conserved as well as quantized. This is a right statement. The second statement says that charge is conserved. That is right part of it, but not quantized. This is definitely a wrong statement. So statement B is wrong. Now the C statement is static charge produce only electric field. That's a true statement. The fourth part is moving charge produce only magnetic field. That's again a wrong statement, as a charge produce electric field whether it is stationary or in motion, and moving charge is equivalent to current, so that also produce magnetic field. So moving charge produce both electric field and magnetic field, whereas the statement says that it produces only magnetic field. So it's a wrong statement. So B and D both are wrong. So here the choice 4 is the right choice. Next problem is a numerical. We have given 2 identical shaped small spheres which when charged act as a point charge acting from center for all external positions, and they have charge plus 5q and minus q coulomb. They are placed in air with d separation, and the mutual force as per Coulomb law given by this expression is given as F. Now they are touched, and after a touch they are placed again at 2 edges of a mica slab of length half of previous separation, that is d by 2, and relative permittivity of mica is if 6. Then we have to find out force in this new position. So when the 2 identical shaped sphere are touched, the total charge, if we add plus 5q and minus q, it become 4q, and it will be equally divided as 2q each. And when 2q at a d by 2 separation in a media of dielectric constant 6 would have a force given by this yellow highlight relation, and it is 8 by 3 kq square by d square, and kq square by d square is f by 5. So new force is 8 by 15 F, and it is opposite to previous force. So if we have a choice minus 8 by 15 F, then that would be even better choice. So the force is 8 by 15 times of previous force with opposite direction, as earlier 2 opposite polarity charges have attraction force. Now the like polarity would have repulsive force. In next question, it is given that force between 2 charges is of same magnitude when they have a separation capital R in air and small r in other dielectric media. We have to find out a relative permittivity or dielectric constant of other media. We know 2 charges Q1, Q2 at a distance R in air will have a force K Q1, Q2 upon R square, where K is 9 into 10 to the power 9. Now when medium is changed, the electrostatic force is inverse proportional of relative permittivity, and at small r distance Coulomb's law force expression is given by this yellow highlight part, and 2 force previous in air at capital R distance and afterwards in other dielectric of relative permittivity epsilon at small r distance is the same. Now here K, Q1, Q2 get cancel out, and epsilon r will become square of ratio of capital R is to small r. So option 1 is the right choice. We have given that 2 identical charges have a repulsion force of F. That means both charges got identical polarity. Now if 20% charge of one body get transferred to another body, then what will be the new force? So let previous each charge is capital Q, and at small r distance electric force is given by this expression, and when 20% of it is reduced and given to another charge, new charge will become 0.8 Q and 1.2 Q, and new force will become 0.96 times previous force. So the force get reduced by an amount of 4%. So this is the right choice, third. We can also remember a fact that if total amount of of charge is divided among two charges, then maximum force is produced when both are having equal amount of charge. As for given sum, the product become maximum when two parts got equal amount. So force depends upon product of charges, not on sum of charges. So for same amount of total charge, when charges are equally divided in two parts, then they would have maximum repulsive force. Now similar type of question got a different answer. Now the two identical magnitude charge have an attraction force of F. That means two charges are of opposite polarity, and if 20% amount of charge of one get transferred to other, then when this positive 0.2 Q charge is mixed with this minus Q charge, it will become negative 0.8 Q, and new force will become 0.64 times previous force. That means force get decreased by an amount of 36%. So option 3 is the right choice in this new case. 2 point charges capital Q and 4Q are placed at 30 cm distance. We have to find out a third central charge such that system of 3 charge remains in equilibrium. The position of third charge should be a position of electric neutrality, where resultant electric field by other two charges becomes 0. So for two like polarity charges, electric field given by this relation would become equal and opposite if capital Q charge produce same amount of electric field as produced by capital 4Q charge. Since electric field is proportional to Q upon R square, so the distance would have ratio of 1:2, so that at 2 time distance 4Q amount of charge will produce same amount of electric field as produced by smaller charge. In general, if two charges are of Q and MQ value, then this electric neutrality position would have a ratio of 1:√m from two charges as indicated here. Now a suitable small magnitude opposite polarity charge minus Q placed here will produce equilibrium on these two charges. So this minus Q charge will produce an attractive force on capital Q given by this relation, and let this distance is small d. So other part is 2d. So the total distance of 4Q charge from capital Q, which generate a repulsive force on capital Q of amount KQ 4Q, and d and 2d become 3d. So inverse square of the distance is 3d whole square, and when we simplify this relation, we'll get that value of this small q is minus 4/9q. And in general, if two charges are Q and MQ, we can memorize the value of small q as m upon 1 plus root m whole square capital Q. And for m square number, root m can be obtained if these two charges are Q and 9Q, then m is 9 and root of 9 is 3, 3 and 1 is 4. So my answer would become 9/16Q with opposite polarity if these charges are Q and 9Q, and for Q and 16Q it is 16/25Q. And same way we can find out other values using this relation. In a charge distribution, positive 4Q and negative Q charge are at d distance, and we have to find out electric neutrality or position of zero resultant electric field. We know in these middle positions, positive charge will produce outward electric field and negative charge minus Q produce inward electric field, and two in the same direction will added together, so there won't be any electric neutrality in between positions. And to second side of this bigger magnitude, electric contribution of 4Q is always greater than electric contribution of minus Q, though both are in opposite direction, but resultant electric field can't become zero. So zero electric field will be possible only to the second side of smaller charge. Then that position would have a ratio of 1:√m, where m is ratio of bigger amount charge to smaller amount charge, and that is 4 here. So this point got ratio 1:2. So x, if this distance is x, and x plus d got 1:2 ratio, and when we solve that, then we'll get that electric neutrality position will have a distance d to the right of minus Q charge. So option 4 will become a right choice here. So for like polarity charges, electric neutrality will exist in between the joining line of two charges, and for opposite polarity, electric electric neutrality will be to the other side of smaller magnitude. Here it is to the other side of minus q charge. In this given yellow highlight diagram, we have to find out force on this central capital Q charge, which is produced at the center of the square, having minus q plus 4q plus 2q and plus q charge on 4 vertices as shown here. So it's a very good example of superposition principle, which says that resultant electric field contribution by several charges is vector sum of individual electric field contribution. Square is a symmetrical geometry, and at central position two vertices got equal distance. So plus q charge and plus 4q charge produce electric field in opposite direction, and that will be obtained as electric field of single charge, which is equal to the difference of these two. So in place of q and 4q, we can either place minus 3q here or plus 3q here. So electric field of two charge can be obtained by electric field of one charge as a difference. Similarly, minus q and 2q could be replaced by a single charge plus 3q at one vertex, and this 3q charge and this 3q charge both will produce repulsive force of 3kq q over x square as shown here. So the resultant electric force on capital Q by the presence of four charges is shown by this black arrow vector, and it is root 2 times of these two forces. One force is 3kq q over x square, and the resultant is this option 4, 3 root 2 kq q over x square, root 2 times of individual force when two forces are of equal magnitude and got 90-degree angle. In the same charge distribution of previous question, we have to find out amount of work done in bringing this capital Q charge from infinity to the center of this square. Now for work calculation, we have to find out potential contribution by these four charges at this central position, and for symmetry of charge distribution, when observation position got identical distance from all individual charges, we can make summation Q technique, and summation Q of all these four vertices charges is plus 6q. So plus 6q charge will produce 6 qk over x potential at this central position, and when we bring a capital Q charge from infinity to this position, the amount of work done is q into v, or 6kq over x. So option second would become the right choice. We have given that potential is 5 volt at 4 meter distance from a point charge whose magnitude is not known to us, and we have to find out force on 4q test charge, which is placed at 2 meter distance from the same source charge. So as source charge capital Q at a distance r will produce electric field intensity kq over r square and potential kq by r. So at same position, when electric field and potential both are given, we can relate potential and electric field by this relation. Now in this question, to find out force, we need electric field intensity, and we have given potential information with distance location. So at 4 meter distance, where potential is 5 volt, we can find out electric field intensity as V by R, 5 by 4 volt per meter. Since electric field intensity is inverse of the square of the observation position distance, so when distance become half, that is 2 meter from 4 meter, the electric field will become 4 times. So electric field at 2 meter distance will become 4 times of 4 meter distance electric field. So it is 5 volt per meter, and in this electric field of 5 volt per meter, when we put 4 coulomb charge, the amount of force will become 5 4s are 20 Newton. So fourth option would become a right choice in this example. We have given a point charge produce electric field intensity capital E and potential capital V at any observation position. Now we have to find out distance of that observation position from source charge, where potential is 1/3 of previous potential, that is V by 3. So from a point source charge capital Q at a distance r, electric field intensity is given by kq over r square and potential is given by kq by r. And if we know E and V, the ratio of E to V is the distance of observation position r, and ratio of V square upon E is kq, and k is constant 9 into 10 to the power 9. So we can find out amount of source charge or the distance of test position if we know E and V. So here distance of test position having potential V from source charge capital Q is V by E, and we know potential is inverse of distance. So for 3 times distance, potential will become 1/3. So at 3 times V by E distance, potential is V by 3 from this source charge capital Q. Similarly, we can find out position of electric field 4E, which is half of this distance, and this distance is V by E. So half would be V upon 2E. Similarly, at V upon 3E distance, electric potential will become 3 times of V and electric field intensity will become 9 times of capital E. We have given a charged ball of mass 10 gram and charge 100 microcoulomb or 0.1 millicoulomb, and this ball is suspended to a support through a wattless 1 meter long string in an uniform horizontal electric field of 100 volt per meter. We have to find out resultant equilibrium position of this string from vertical, or we have to obtain this angle theta here. So this ball with mass 10 gram have a gravity force mg vertical downward, and uniform electric field will produce electric force in its own direction on this positive charge, and two force would have a Pythagoras resultant equilibrium QE square up plus mg square square rooted, and the same is balanced by tension in the string. Now the equilibrium position of string will take theta position. So tan theta here is a ratio of electric force to gravity force, and electric force on 0.1 millicoulomb or 10 raised to power minus 4 coulomb in 100 volt per meter electric field is 0.01 Newton. Similarly, 10 gram or 10 ki power minus 2 kilogram in gravity of gravitational attraction of 10 meter per second square will have roughly 0.1 Newton force, and ratio of electric force and gravity force is 0.1, and when theta is small and in radian, then theta and tan theta become equal. So theta is 0.1 radian, and 1 radian is roughly equivalent to 57 degree or 60 degree. So approximately this theta become equal to 6 degree. Please note that tan theta become equal to theta, but that theta is in radian unit, and pi radian is equal to 180 degree. So with that conversion, we can convert radian into degree without using any calculator if we know small value of tan theta or sin theta. Key to the success in modern competitive exam is do solve as many pattern of questions as possible. So we will discuss 10 different patterns of examination question in each of our Physics Made JEE MCQ series videos, and do view all our videos and make similar type of practice for surety in your examination success. We end here only, and we appreciate your interest and support for our videos. Thank you very much.